So welcome everyone who joined us today here in London, and for anyone joining us anywhere from the world. I truly appreciate you making it today and joining us for this roundtable informal discussion for real-time stream processing. So when I joined Hazelcast, I truly believed in the capabilities of Hazelcast in terms of real-time stream processing. So the event today is going to highlight these features and show you what you can and what you can achieve with Hazelcast, and obviously with the roundtable discussions from experts in this domain, you will probably start to feel what's going on in terms of what you need to do and how you can use it in your work, for example, or even for your career as well. So first of all, I would like to thank those who attended the workshop today. I hope you managed to get something out of it, and we're staying around after this event. So if you still have any question about the workshop, feel free to reach out to us and tell us basically if you have any question. So my name is Fawaz Ghali. I am from Liverpool, Northwest in the UK. So what I wanted, basically, I know that's you guys here in London, so but what I wanted from everyone online, just to type in where you're joining us today, where from, and basically where you want us to host this event next. So that would be really good. So I wanted to kind of give you an overview for our community, why it is important to be part of this community, and essentially just to give you a sense what we do and how can you also contribute. And I would love to hear from you. This event is mainly about you. It's not about Hazelcast or stream processing. It's mainly about you. We would like to know exactly what type of problems you encounter, essentially what keeps you awake at night. If you have a discussion with your line manager, and if you have some kind of problems at work, obviously related to stream processing, because that's what we're talking about. So kind of, I don't want to like problems anywhere. It's just like specifically about work, what kind of problems you have, and what we can do. So there is no way, basically, for a solution, regardless what this solution is, to make sure that you can use it without knowing the problem, without knowing the use case, without knowing what you need. There's no way, basically, to decide which tool or which platform you want to use. So obviously, we don't know everyone's background today, especially for people or folks joining online. So it's hard for us to pinpoint exactly how to deliver a message. So currently, we're kind of looking at it in the big picture. So that's what we want to start off, just to make sure this point is clear. So for example, if you're working in business, for example, what kind of problems you encounter for stream processing for real-time analytics? This is the exact starting point. If you're not working in business, maybe you're working in IT, or majority of us working in developments, engineers, data scientists, and so on. So how do you decide which solution to use? So we want to make sure to answer this question, but obviously we want also to hear your opinion. So those who are online can join these questions. We will post it in the roundtable discussion. So it's not only we want to approach it from Hazelcast perspective only, but also we want to hear community what they say. The roundtable discussion is mainly about experience with real-time stream processing, what tools you need to use, and obviously focusing on the core concept of real-time stream processing, because not every solution gets it right. And the DNA, the core concept of real-time stream processing, comes into place where we combine two different concepts. So we combine the concepts of stream processing as well as the fast data storage, because you can't do real-time analytics and you can't act instantaneously without providing some kind of context. So that's what is important. So that's the core of real DNA, or the DNA for real-time stream processing. Obviously, we want to, you can use 10 tools to approach your goal, but this comes at cost in terms of, development time, maintenance, and obviously cost of running these solutions. So what we want is to focus on simplicity when it comes to do this real-time analytics. So if you hear real-time, this term tend to be, ambiguous. So not everyone has the same definition for real-time. So traditional way of real-time, or what we call it as close or near to real-time, there is some kind of delay. Basically, you get data, you try to store it in your database, and then you do some kind of analytics on this data. So this is kind of like traditional way. What we wanted is to kind of avoid this delay. We want to act on the data as we receive it. And this is what we will focus on today. So we will focus on saving time, but at the same thing, obviously, we want to have a simplified approach where you don't need to have multiple tools to do it. We just need to see what is needed. And as I mentioned, it's kind of like looking at it from your perspective. Obviously, this is your event. So what we wanted is to give you some kind of flavor of the Hazelcast community. And this is really important for us because it's not a one-man effort, it's not team effort. And when you come to the community space, it's kind of like you share experience, you give back. And that's what we focus on at Hazelcast. We try to focus on your contribution, your importance in terms of how you use this tool. And we use 3 different concepts in it. We use kind of like a platform where we try to make things easy for you in terms when it comes to real-time stream processing as community. So it becomes easier for you to ask questions. Obviously, it becomes easier for you to contribute if you would like to contribute to our platform or anything you want to do in terms of the real-time story. And also what is important is that's basically you're part of it. So this is the message here today. It's very important, especially for folks online, to make sure that, feel free to share with us now online any question you have about real-time stream processing. Of course, we will describe the future of real-time stream processing, but at this stage, what kind of problems you have? Obviously, you folks here in London, we're staying around, or if you want to join online as well to ask questions, you can do so, or we will have also roundtable discussion as well. So it's your time, basically, to be part of this. There are various ways to do it, so we're not saying that you need to follow one way or another. It's just kind of like what attracts you most. How do you feel comfortable? Because after all, when it comes to the Hazelcast community, we try to put you at the center of it. So in terms of community, we do meetups, and these meetups tend to be, whether it's offline or online, we always try to make sure that you're engaged, we get your feedback, which is quite important, and obviously we focus on creating some kind of content which is relevant to what you do. Obviously, you want to know more, so hopefully I managed to get you excited about Hazelcast. If you don't know what Hazelcast is or what it does in terms of real-time stream processing, but at this time, what I wanted is like to give you some time to leave your questions, and I will leave this stage to our Chief Product Officer to tell you more about Hazelcast, what it does, what it's currently doing for real-time stream processing, and the future for real-time stream processing. So I will hand it over now to our Chief Product Officer, Manish Devgan, who will basically describe this. And essentially, after this talk, it's like 10 minutes talk, so it's not going to be long. We will have the informal roundtable discussion from experts in this domain who are working in this area, and you will hear different stories, but obviously it's like their perspective. So I would really like to invite you to be part of this discussion. After all, if you want to know what you need to use in terms of solutions, you probably need to describe your use case, right? You need to describe your problem. And once we know the dimensions of your problem, we can suggest the best solution to approach it. So with that being said, It's going to be a really nice and fun event. We will have a quiz afterwards, after the roundtable discussion, and there is a chance to win a Nintendo Switch, which is pretty cool for people here and for those who are joining us online. So stick around, ask questions, and let us know how we can help. It is very important to get your feedback, because after all, as I mentioned when I started, it's like it is your event. So take this chance to ask questions and let us know how we can help. Thank you. Manish? So I would like to welcome to stage our Chief Product Officer, Manish Devgan, who's going to describe the future for real-time stream processing. So if you have any question for me or Manish, leave it in the comment sections online, and we will make sure to answer it before we start the roundtable discussion. Thank you.
Thank you, Fawaz.
Cheers.
Thank you.
This is for yeah, sorry. My boss asked me to take selfie, if that's okay with you, with the audience.
Yes.
No, with you. So just make a selfie. All right.
All right.
Cheers.
Thank you, everyone.
Thank you.
Hi, everyone. My name is Manish Devgan. I'm the Chief Product Officer at Hazelcast. And today I'm going to talk about the future of stream processing. This is a report from McKinsey, one of the management consultants. And this was a report last year. And they talked about these characteristics for a data-driven enterprise in 2025, so not too far away. And there were many characteristics they talked about in a data-driven enterprise. You know, data is part of every decision, every process. And one of the things they mentioned there was about real time. And you can imagine that if a consultant like McKinsey is talking about it, is definitely something they have been talking to, the CXOs of various companies, and they see that trend. And I wanted to kind of quickly iterate on what was the this characteristic about the real time which they mentioned. McKinsey said that there are a couple of things happening today. So this is the state of the union today, that there is a fraction of fresh data being used. And some of the stuff which kind of inhibits the value of real time is the architectures today, right? And they also talked about how there is a need for modernizing architectures. I mean, people are dealing with legacy architectures, so there is always this notion of how do I bring new technologies to the existing systems. So there's always a tug of war there. And then they talked about in 2025, what are the things which are going to be happening? There's definitely going to be a dramatic transformation for real-time data processing. We talked about in-memory architectures, which are going to become mainstream. And also some of the more advanced use cases, which will really get to leverage real-time data processing. So we are already on this journey, and we see at Hazelcast, we see a lot of our customers already leveraging some of these real-time insights. And people have different perspectives of real-time. A lot of people talk about real-time in the context of latency. And what we feel is that we have a little different point of view on what real-time is. But if we look at the spectrum of use cases of our customers across the board, across industries, we see that they are always seeking this particular SLA. So there is this almost like a latency continuum out there. We see use cases which are like in the microsecond range. And these use cases are mostly around high-frequency trading applications. So these are one of the few use cases. And then when you move to kind of between microseconds and sub-millisecond kind of range, you see a whole slew of use cases around fraud. We have a lot of banks and credit card companies who use Hazelcast. So those use cases are there. A lot of the use cases are around how do I optimize my customer experience. So I want to be able to process data in sub-milliseconds. So those are the category of use cases. And then when you move to the right, there are a lot of streaming analytics use cases where they may lie between few milliseconds to even a second, right? So the point here is that there are all these use cases across this time continuum. right? So real time does not just mean fast. I think that's a lot of, there's a lot of buzz about, oh, real time means fast, but we actually have a different point of view. Our point of view is that it's more of a business term. It's about a business SLA which you're trying to reach. So if we look at our customer base and our user base, we also have an open source. We have a couple of open source projects, so we have a lot of users using our technology. And when we look at these real-time use cases, it's always about kind of seizing that moment, right? How do I derive real-time insights from the data which is happening right now? So a lot of the use cases we see are, while the customer is banking, can I actually afford my customer a real-time offer based on their current situation and current profile, right? And we see when a customer is shopping. So it's always in the moment. And if you look at all these use cases during a fraudulent event is happening. So as you are transacting, you want to know before that fraudulent transaction, the person actually leaves the store rather than 2 days later. So it's always in the moment. So our view on real time is that it's more of a business term. It's about meeting a particular business SLA. Now, if we look at the real-time perspectives in the market, and I want to mention this because as you're solving your problems and looking at various technologies in the market, you may want to look at this perspective as well. Our perspective is that there are technologies which give you fast access to data. So these are we call it just a faster horse. So if you have a database, you may want to look at an in-memory database or a database which is fast. There are very good platforms out there which give you fast access to data. These also include in-memory data grids, right? So basically a faster way to access data. But we feel that this is not that high value. It is one part of the broader real-time equation. If you look at, if you go beyond, if you go to a more moderate level of value which you can provide by a platform, you see a platform which do streaming analytics or stream processing, right? But they don't afford you a low latency data store, and all that wiring you have to do yourself. And then comes the real high value in real-time applications where you have a combination of stream processing and also context enrichment by actually having almost like an embedded low latency store with it. So we feel that when you're looking at building real-time applications, Fawaz talked about this DNA, where if you look at that DNA helix, one of the strands is low latency data store and the other one is stream processing. Because a lot of times we see our customers struggle with the operational complexity there is when you're trying to wire these two systems together. Now, while we are looking at this perspective of real time, I also want to highlight, what are the things happening today, what we see in our customer base. We see many things. So one is that we see this drowning in decentralized data. We see customers having multiple data stores in their companies, and so the data is decentralized. The data is also, there are copies of the same data as well. So there is complexity because of that. Then we see that there is this new foundation of competitiveness. We see our customers also in a hyper-competitive environment, especially if you look at the macroeconomic turn here. They have to find out ways to make more revenue or protect their revenue, right? So there's hyper-competitiveness happening. We also see that, developers are really calling the shots, right? They are dealing with bigger challenges, but they're also kind of deciding what technologies to pick for the solutions. And then we see that a lot of the solutions which are available, if you look at a particular data platform from one vendor to the next, people are gravitated towards solutions which are simple in the sense that, you want to actually be building your business application on top and not worrying about the undifferentiated heavy lifting you have to do with a distributed system, right? And for, vendors like us or, open source project leaders, what is also very important is that we need to engage with developers, right? And really understand what the problems they are dealing with when they build these solutions on the top. So again, this is, that's why we are having this conference, to hear your input and for people online to hear their input, and make sure that, when we deliver a solution for you to build real-time applications, you're well taken care of. So as you see, this is what's happening around us. We also want to I want to talk a little bit about the future of stream processing, and we see that there are these core critical capabilities which people have to pick and choose when they're building a real-time application. This is kind of the blueprint or the trend we see in our customer base. One is real-time messaging and streaming. These are vendors which are basically which allow you to move data from one place to the other. These are messaging systems. These are like Kafka is one of them, modern systems which is out there. There are other traditional systems like IBM MQ and Solace and the like. But this is a critical capability you need because you need to move messages around or actually be able to subscribe these events. And then the next thing is we'll see real-time data integration. And data integration is all about, how do I move things from source to sink or actually tap into various data sources. That's another critical capability. And then comes real-time data management. This is, again, I talked about, something which will let you have access to data fast. And then another critical capability is stream processing. This is for you to be able to process streams of data or fresh data which is coming in. And then real-time analytics, which is about fast querying or continuous query or querying a materialized view, for example. So you don't have to depend on batch queries. And then comes real-time ML. And this is fairly new, and we really see an uptick in our customer base where people are actually using real-time ML, not so much so to train the models, but actually to inference these models. And we believe these are the critical capabilities which enable the use cases around real-time applications, right? And these are the use cases span from e-commerce, retailers, to healthcare, to financial services. This is my last slide. I want to talk a little bit about, now focus on the stream processing platform. And when you're evaluating various solutions in the market, the things which are very important is, one, I talked about messaging. We call it flow here. But basically, how do you connect and deliver data from sources and sinks? That's going to be a key capability, right, in the platform which you evaluate. And then would be analytics. Can you do analytics on fresh and event-based data, right? This could be basically calculating aggregates or determining patterns in a specific time window. And then the ability to process data, not only fresh streaming data, but also data at rest. So a platform which kind of enables you to do that is going to be very key. Because today your use case might just be about processing a particular stream, but what if you have actually to tap into the context of the stream coming in? And then, of course, a low latency data store, because if you connect stream processing with a disk-based database, that's going to fall over because you're not going to be able to meet the business SLA you need. And then comes real-time ML. And real-time ML is, of course, about online prediction, but it's also about not only training models in, let's say, a data lake or something like that, but also be able to have access to real-time features, right? The features which your ML model is going to tap into while inferencing or while making a prediction. So with that, that's the last slide. I have my contact details here. If you want to reach out, if you have questions later on or need more information, happy to engage. And also, feel free to access some of these capabilities we talked about in our platform. The cloud service is called Viridian, and please sign up and see the art of the possible. So I really encourage you to do that. Thank you very much for your time.
Thanks, mate. I think if you can stick around for the questions and then the round tables.
Yeah.
So the plan is just kind of like, we have small short Q&A, basically, just to go through these concepts. Like, I really would like to know, basically, how many of you are currently building real-time applications here? Those who are online, you can feel free to. That's good. That's good. So I think this is really useful to know, like, how does it work in real time when it comes to basically, process data at scale. And we got some questions, but let's just start with like people who are currently attending here. So any question from you guys about the real-time stream processing or what is possible to do, anything related to the use case you currently have? We have some questions online as well. Okay, I think we go online questions. So Manish, you described the real-time stream processing in terms of providing solution at this current moment, right? But how does it work if you basically have one of the two components? So for example, if you just have events, what do you suggest to do in this case? So we got a question basically is like, I run a Kafka application, how can I do real-time stream processing on top of it?
Yeah, I mean, we work with Kafka. In fact, majority of our customers use Kafka. Kafka helps either ingest events or any kind of stream processing or transformation, and we do that. I think what's important to, when you're building a real-time application, you looked at, you saw the critical capabilities we have. Especially if you're using Kafka, I think the two other critical capabilities you need is a low latency data store and a good stream processing engine. An engine which will allow you to process both data in motion and data at rest. I think that's very key. And that's why a lot of our customers who use Kafka leverage these two, the store as well as stream processing. And what really helps them is that it's all in one runtime. Yep. I think that's the key, because then they don't have to deal with all this complexity which comes in standing up to scale out clusters.
Yeah, so I think we just need. So the other question we got, like, how does it work in terms of real-time stream processing and cloud? So is it possible to do it like on the cloud, or it has to be like?
Yeah. In fact, we recently released, as in last year, we released our cloud service called Viridian. And that's the link I had in my slide. But it basically affords you both stream processing and low latency data store all in one cluster. And that's a good way to actually test out, if that'll work for your use case. But what we are doing there is that, a lot of customers have moved to public clouds already. So we are offering this cloud service in a managed way and also in serverless. So you don't have to really worry about scaling out the cluster. If the workload so requires, we do that automatically behind the scenes. And we also optimize cost, because cost is another big thing with a lot of people who have workloads on the cloud deal with. So that's really encourage you to go to Viridian. Yep.
So someone is asking about simplicity in deploying real-time solutions. Could you just describe use case where, because we mentioned simplicity, right? But it might not be clear for you, like, what does it mean in practice when it comes, if you want to create or develop a real-time application? So could you just describe what does it mean, like, to have a simple real-time solution?
Yeah, I mean, the simplicity comes in many ways. We, as a solution provider, we are very focused on the product experience, like how, if you're a developer, do you have the right APIs? Do you have the right documentation to build your solution on top? But also, more importantly, there are things which you don't really, I call it the undifferentiated heavy lifting, where a lot of people have to do in basically setting up the cluster. So we make a lot of things simple in that way, because we know that a lot of developers are actually looking for building their solution on top and not having to turn all those knobs and switches in our cluster. So that's about providing our customers with the best experience they have.
Yep. I guess also part of it is the connectors. So basically when it comes to linking sources where you collect your data from, is simplicity is like how many sources can you link to your application. So could be coming from Kafka, for example, it could be coming from messaging queue or the IoT device and so on. Same thing when you want to sync it or send it out. So I think that's pretty much. Any questions from the audience here? Would you like to know anything, or do you have any specific question or problem or use the case before we start the roundtable discussion? We will have another session towards the end, so if you still have any other questions, so feel free just to keep your question, and then we'll collect it after roundtable discussion. So let's just set up the stage. Some speakers will join virtually, some speakers will be on stage. So give us like 1 or 2 minutes just to sort it out and basically start the roundtable. Thank you.
Okay.
So the fact is, this is a hybrid event. So we have some speakers here on stage, as well as some speakers joining us online. So I just need to make sure that logistically everyone is joining online. We currently have 4 speakers online, but perhaps we start from on the stage. So perhaps like you introduce yourself like 1-2 minutes, and then we take it over the speakers online to introduce themselves and their own experience with the real-time stream processing. So would you like to start, Aftar?
Hi everybody, my name is Aftar Rekma. I support the Hazelcast platform as head of engineering for the Hazelcast platform itself. I've been with Hazelcast since last year.
Cool.
Yeah, Manish Devgan, head of product for Hazelcast. I joined Hazelcast June of 2021.
Karthik Tope, as Manish was introducing Viridian, so that's what I manage the cloud engineering team, and our push towards making it easy for you guys to run Viridian in the cloud.
Good. Can we get speakers online, please? Hey, Tim.
Hey.
How's it
Tim
going?
Span.
You're on screen, actually. All right, good to see you, actually. I can't see you this way, but it's good to see you. So perhaps like 1 or 2 minutes just to introduce yourself, please.
Sure. Tim Span here, coming to you from the United States. I'm the principal developer advocate for data in motion at Cloudera. That's things like Flink, Kafka, NiFi, all those kind of cool streaming technologies.
Yeah, may I continue? So hi everybody, my name is Günther Hesse. I'm from Germany, Berlin, and I now work at Volkswagen, where we build a group integration platform, so for the entire Volkswagen group. But before, I did my PhD at the Hasso-Plattner Institute in Potsdam, Germany, and there I focused on benchmarking of data stream processing systems. And that's where I came in touch with Hazelcast, Flink, and other stream processing systems.
Thanks.
So I'll be next. Mateusz Kotlarz here. I'm from Krakow in Poland. Currently, I'm working in BNP Paribas Bank Polska. It's a Poland branch of the group BNP Paribas. I'm in integration and stream processing team. We are doing stream processing on our core systems and satellite systems. And I'm using Hazelcast technology for around 6 years.
Good to see you. Hey, Vijesh, how are you?
Right. I'll go next. Yeah, I'm good. Thank you. So hi everyone. This is Vishesh joining in from Bangalore, India. I am currently working with AppDynamics Cisco. So it's essentially an observability company where stream processing is the key enabler of observability, right? So that's how kind of started exploring in the stream processing domain. Eventually got in touch with the Hazelcast community, worked, had a short document with Fawaz, and looking forward to this discussion.
Good. So let's just get things going now. So the first question is in terms of current trends for real-time stream processing. What's going on, like in terms of trends? What type of solutions exist, Tim?
Sure. Yeah, there's a lot of things coming up and building up right now. Real-time stream processing is very exciting. There's a lot of different vendors out there, a lot of open source projects. Some of the things out there, more advanced managed environments, more support for containers, more different options for real-time analytics, different fast storage options connected to real-time streaming. SQL is everywhere. Kafka and Pulsar are usually used as the messaging protocol or hub. And we're seeing Java finally moving up to at least version 17 for most services out there, and also support for things like serverless environments.
Yep. And Gunther, anything you want to add for trends? I know like you've done some work previously with the benchmark for stream processing. Any updates from your side?
Yeah, I basically agree with Tim. So there are many new technologies and systems that have been built around last couple of years. And yeah, now with new technologies emerging, like right now, many people talk about things like data virtualization as well, and easy access of data, and then we can come to simplicity again. But yeah, a lot of movement in the marketing, and so it's kind of a challenge for us to basically find the right technologies and not to overload us with too many technologies, basically.
Okay, over to you, Matthias. I know you use stream processing every day, so it would be nice to hear your side of the story.
Yeah, we are using stream processing in our daily work. We created the platform for the CRM mostly because we needed to have our offers offer some to the client as soon as possible. But we're thinking about expanding that because we see huge potential in the fraud detection probably. Of the real time, also anomaly detection, or maybe some monitoring of the systems in the IT. So there are huge possibilities. All we need is the data on our some, like you said, a Kafka or any other real stream data ingestion. So the most important thing right now is to have idea how we can use the real time and find the field when we can feed it, because platform is pretty grown till now. So
right, thank you. Vijesh?
Yeah, so I think everyone pretty much summed it up really nicely on the current trends which are going on in the real-time stream processing, right? But let me just put out my thoughts on terms of what I believe. What I believe real-time stream processing looks like from let's say from an observability point of view, because that's the closest I've been with the whole domain, right? So I also would like to call out what Manish was talking about earlier, where it's not just about writing your business logic. It's about how you get your data to the code which executes your business logic, right? So it's you may write your stream processing engine might be very quick, but then your whole packet flow from origin or till up until it reaches the source of your processing engine, that is also very critical in terms of real time. So that is one thing which I think we should look out for. And another thing which I see going on is the no code or low code, so to speak, trend, where we started, let's say, talking about Kafka streams, right? Kafka streams was even before Kafka streams there was Kafka, and you need to set up your consumer, you need to handle your processing guarantees, so to speak. And Kafka streams came along, and it kind of solved some of these things for you. But then again, you still had the overhead of maintaining the whole service actually. And then when combine it with no code or low code, Kafka streams and Micronaut will just provide the configuration, and your service will start running. Now, taking that to a next level, taking Hazelcast for example, or Flink for example, they just provide the platform to you, and you just worry about your business logic. I think that is also something which Manish touched upon, that you don't want to do the heavy lifting while writing stream or doing stream processing analytics. You just want to meet your SLAs, and your platform should actually worry about all of the other operational related tasks. So yeah, that's kind of what my take.
Thank you. After, when it comes like to engineering decisions, so what do you look at in terms of trends for stream processing? How do you decide what features? Yeah, it would be good to hear your perspective on trends for stream processing.
Yeah, for us, I guess from an engineering perspective, there's really 3 time horizons that we're really looking at the problem. We're looking at what are the customers wanting today, what are the problems they're trying to solve today, and a lot of that is around being able to put in your business logic and just let it run. I don't want to spend my time configuring, I just want to be up and running, and that's great. So we have that. Then we look at the near-term time horizon, and that is now the trend we're seeing is actually companies want to have a whole platform out the box. They actually don't even want to go down the path of building anything. They just like to be able to wire some parts together and have it run. So we're kind of now looking at that at the next level. And then you look at the time horizon sort of even further out, the 24, 36, 48 months out, where are our customers going to be? And there you're looking at bringing real-time ML analytics to the customer as soon as they can possibly use that data. And so now we're looking at making the right engineering decisions to enable those kinds of capabilities. So essentially, that's typically the thought process that I have to go through, which is, are we addressing the customer market today, tomorrow, or the future customer market, and make sure that we're getting that balance right.
Okay, thank you. So jumping to second question, Tim, what challenges you currently have in terms of real-time stream processing, and how do you approach these challenges? What solutions would you say are possible to do in terms of real-time stream processing?
Sure. Yeah, there's a lot of difficulties out there. I think the first one I see, and is kind of the last portion of it, is deployment. If you're trying to deal with just open source and you don't have some data platform to deploy to, setting up deployment, figuring out how to automate it, manage it, monitoring it, that can be really difficult. It may not be too hard to write your app and run it locally, or run it maybe in Docker. But then when you want to deploy it to a production environment that's maybe hybrid, different clouds, a lot gets involved there. And in the pure open source, that's a little difficult if you don't have some kind of platform behind you to support that. Along with that, I see a lot of people having problems trying to size your project or figure out the right components for a use case. You know, not every single piece is needed for everything. Like sometimes they need Kafka, sometimes they need Pulsar, sometimes there's Flink, sometimes there's NiFi, Hazelcast, depending on who's writing the code, what are their skill sets. We mentioned low code, something like NiFi, where I could do the simple stuff quickly, get data into a stream, say into Kafka, so I could hand it off to a Hazelcast or Flink to do some complex event processing. But sometimes I need something just simple event processing that could be handled with, you know, something inside of Kafka or a Pulsar function, or maybe a NiFi where you're just doing something simple, maybe some simple enrichment and not complex event processing where I'm, you know, combining multiple streams. I see figuring out what you should do. That's a difficult one.
Yeah. Thank you. Gudner, from your side, what challenges you see in real-time stream processing?
Maybe unmute.
I think you're muted.
Oh, sorry, I wasn't good. Yeah, thank you. Yeah.
It's always when you do Zoom online, is who's gonna be the first person to say you're muted? And I think if we make a prize, basically, you would see, well, if we make a prize the slowest, people still say you're muted the fastest for whatever reason. So, sorry, go on.
Sorry for that. Yeah, but I agree. One question that we face is certainly like about when to introduce a stream processing system. So when is NiFi or any microservices maybe developed using also a low-code environment? When is that not enough anymore? And when would it be beneficial to basically introduce a stream processing system, stream processing platform? And yeah, when we would be benefit from that by either having a more a simpler solution for doing data transformation, streaming analytics, or would it give us like opportunity to handle use cases that we haven't been able to handle before? So that is certainly one question that is always around. And I think a second, big challenge is spreading the knowledge about stream processing systems and stream processing technologies. I think we are all aware of different technologies like Hazelcast, Flink, and the other systems that have been mentioned or that we might know. But I think many people out there in industry haven't been in contact with such systems still. And so it's just, they do not right away think about using such systems for tackling their challenges. And so I think, as a second pillar, it is important to spread the knowledge to a broader audience regarding stream processing systems and the like.
Okay, thank you. Matteo, I know that you do it like full time, so I'm pretty sure that in this case, you have so many challenges and problems, on your work. So what's your take on challenges for real-time stream processing?
Yeah, the first challenge we had, it was that we wanted to use the real-time stream processing, not only for developers. We wanted to provide some platform to analytics, maybe sometimes testers, because like Tim said, there is a huge overwork on the setting up the whole platform. So we need to create some Docker, provide some configuration of Kafka, some probably repositories, some IMDGs. And if for a small project, there is no need to configure everything by every team in the organization. So we tried to create the platform when there was some DSL or something like that, and the user could use the real stream processing with our company data by some UI. So there are some blocks when you can drop the Kafka from which you want to read something, and then do some Python job maybe probably, then add some ML engine, and then send probably SMS or email or anything you want to have on your sync. So that was the main challenge we faced because there are some lack of developers sometimes in some teams, but we need really to have the process done and the product have the product on production on the deadline. So if there is such a platform, so it's easier because we only make development to this platform and add some additional features to this platform, and users can use that. But we face right now one bottleneck about enrichment, because enrichment is pretty great. It's real time. We can get information from the context, from probably information about some customer, about some product he have. But sometimes we have enrichment which is pretty slow. So we can. This is the bottleneck of the stream processing, because we have one stage which is pretty slow. The whole pipeline is slower with that one stage. So right now we are trying to speed up some stages, some databases, some enrichments, to have the whole pipeline and whole platform stable. So we see potential in that field. How that maybe some caches. Yeah, we are thinking about that, what we can do better in that field.
Thank you. Vishesh, what kind of problems you currently have with stream processing?
Right. I mean, there are endless problems, right? I think what I believe is the sheer scale at which real-time stream processing operates, at the kind of volume of data you get, you need to design your systems accordingly, right? Again, your volume of data may not be constantly flowing at that rate. It may go up and down, and you might want to try to scale your resources based on that. There is that angle to it. Then there is an angle of data sources. You might not have just one single data source. You might want to combine multiple data sources into one single stream and perform some correlation out of it, or generate some meaningful information which would help you better understand what is going through your system, right? That aspect is there. I think that is where that is where the whole different adapters come into the picture. Let's say you want to consume from Kafka, you have a Kafka adapter. Or let's say, if talking about Hazelcast, you want to consume from an IMAP, then there is an IMAP source which you could use to. So these are some of the things which we need to look out for. And of course, there is this latency aspect, because from my experience, what I've seen is that if let's say you wanna do something based on the data you're getting, and if you want to do it quickly, there is no point if your processing is slow. So the latency aspect is also there, and then there is the whole throughput aspect where you try to come up with, or not even come up, you try to predict what kind of scale your data is going to come in, and what are the kind of resources you want to provision. So those kind of things is what I've faced.
All right, thank you. So I want to take this question a step further. I want to understand what's going on if you want to deploy it on the cloud. So what kind of challenges, Karthik, would you say exist, and solutions?
Great question. I think all the experts sort of hit the nail on the head, right? You have an application you're building, and your focus predominantly lives on how do I build that application. But as you get into these platforms, it's very difficult to build a platform, maintain it. If you're lucky enough to do that yourself, you have a team of SREs that are monitoring the application. And as I think you guys clearly said, your cadence of data that's coming in could differ. So what you might be running today, 5 clusters, would be 10 clusters next week, and it goes up and then it has to go down. So all of that complexity is there in managing these. By running it on the cloud, our goal is that we sort of simplify the entire process for you guys, right? So you set up the clusters. We sort of been at this for a long time. We know how to set up a cluster in a highly performant way, right? So that by doing that, we provide you you can focus on building your application, and sort of we manage the backend systems for you. And that's good. And the other most important aspect to me, I think, that we sort of haven't mentioned is the cost of running these in the cloud, right? Whether you're running it on-prem or on the cloud, it is expensive. You can easily get out of control, right? So that's where having it scale as you need, when you need it, and then bringing it down when you don't need them is the best way to sort of optimize your infrastructure and sort of reduce the TCO. Otherwise, you'll be spending a lot of money, constantly, and that's a big challenge with any infrastructure you run. So,
yeah, I think the cost is an important factor for this.
Really.
What is really important, I think that's the main question everyone is asking about, is kind of performance. So when you look for solutions, obviously you want to look at some kind of benchmark results, and usually benchmark is not easy. So we want to have an answer, basically. How do you approach stream processing in terms of performance and benchmark? But for those who are online, you can jump in and ask questions if you have any question, or if you have any take on any of these questions. So over to you, Tim. What do you think about performance and benchmark when it comes to real-time stream processing?
Yeah, this is a really difficult one. I mean, there are some benchmarks available. Some vendors have put benchmarks out there. Some open source projects have. There are a couple of open source open benchmarks, like the open messaging one, that'll let you run it yourself. But for the most part, you see a vendor ran a benchmark for their tool, and surprisingly, it turned out really well. That doesn't mean that's not valid data, but they're really the only way that it makes sense is for you to run it in the environment that you can afford, that you have access to, that you understand, unless you're doing something where you talk to a lot of vendors and do an open, demo run for each of these environments. Because for one use case, your thing might run well in anything, or it may require very certain characteristics, like mine can only run in this version of Java, or it has to be in this type of Kubernetes environment, or, it'll run well if I have a ton of RAM. This is a tough one. Usually you have to start somewhere that you're comfortable with, find a use case, because you're not going to get performance in every use case for every environment. I'll send out some links later for people to look at the different benchmarks out there, but you run it yourself and you find out I didn't do as well as someone else. Maybe their environment could be more tweaked. They have newer versions of the OS, newer versions of the JDKs out there. There's some big difference if I'm running JDK 8, 11, 17 or greater. You can really get massive optimization without doing much other than making sure you're running the latest stuff. This is not easy. This is not an easy one to do here.
I agree. Actually, when I looked at it myself, it's kind of like hard to approach it from customers in terms of how do you look for benchmark when it comes to actually comparing tools. Actually, you can do a PhD about it, and I forgot to mention Gunther, Dr. Gunther, actually has done his PhD around benchmarking stream processing. So I'm really looking forward to your answer for this question. So I think everyone here in London as well as online are looking to your answer. So what is your take about performance and benchmark for stream processing?
Yeah, thank you. Tim really nicely explained his observations, which basically mirror mine. So when I started my PhD there, there have been some vendor benchmarks, vendor measurements with some well-looking results, but the area of benchmarking wasn't as well developed as for databases, for instance, where we have many, basically standardized independent benchmarks like the TPC-C benchmark, TPC-H, and so on and so forth. But there wasn't anything like that for data stream processing systems. So when I started having a look at it, I found the linear road benchmark as probably one of the most famous benchmarks back then, and used it for comparing Flink and Spark. But yeah, I felt that it lacked some aspects, certain aspects, and it wasn't really fulfilling or satisfying to me. So that's why I came up with the idea to develop a new benchmark for, basically benchmarking data stream processing systems, data stream processing architectures. So where I developed a data center, so data ingestion tool, a configurable ingestion tool, for instance, as well as a result validator that also checks if the results calculated by the system are correct, which is a little more difficult than for database benchmarks, where you just basically execute a select statement and check if the result is correct or not, and it's always the same usually. And I basically developed a new benchmark and published it, and also to prove the functioning of the benchmarked three different systems, Hazelcast being one of them. And the results are published, and the benchmark tool is open source, so you can check them out and have a look at them yourself. But what I can say is that Hazelcast performed really well compared to the other systems, which was quite a surprise to me, to be honest, because I didn't know much about Hazelcast before. So I heard about Flink, about Spark.
Just to stop you here, just to clarify, this PhD, this research wasn't funded by Hazelcast. Is that correct? We didn't pay you to say this.
Not funded by.
All right.
Not funded by any.
Just wanted, to clarify it. Yeah. Okay. So what advice would you give to people if they want to benchmark? So how do they approach it?
Basically they could, of course, use the benchmark I developed that is available for everybody to use. But if there's somebody out there, I would probably give the advice to tailor and customize it as far as possible to really benchmark the environment and the setting with the throughput, latency requirements, and so on and so forth that people have on the one hand side. On the other hand side, also, I would encourage people to not only investigate the most popular systems, but maybe also one or two systems that are not that well known, because results can be a surprise.
Okay, thank you. So Matthias, from your side, do you do benchmarking or do you test performance? How do you approach it?
Oh, this is a tough one because we are doing benchmarking, but this is not that easy because really a lot of things depends on the architecture and on the infrastructure we have. Because on the test environments, probably we have another machines, not the same as in the production. I don't know, sorry about the cloud, because we are not able to use the cloud, so I cannot tell about how benchmarking in the cloud looks like. But if we have some database like Gunter said, which is probably slow, and then the whole benchmarking of our stream processing will be not comparable to another environment. Yeah, so this is a pretty tough stuff. Yeah, it's really difficult to feed the stream before all the processing also. So we need to have any idea on the data which will be taken to the performance test and the benchmark of our stream processing platform. And because if we put some nulls or something like that, then probably all pipelines will do nothing and the benchmark will be great and the reports will be fine. But this is not the truth because on the production we will see that everything is not as fast as we were thinking about that. So yeah, I guess the main problem is the infrastructure we have under the real time and the data we are feeding to the stream.
Okay, thank you. Vishesh, from your side, do you do a benchmark?
Yeah, so I have some experience with that. Not a lot, but I think I'll probably do a +1 to whatever the other folks just talk about. I like to add one small thing which I've seen really helps in benchmarking is that if you tailor your data to the to match or to match to what is it is going to be like in production, that is a really helpful thing which we see. So usually typically what happens is at the time of benchmarking your data is kind of you try to mock data, right? And sometimes there are misses in the replication part where you don't really pay much attention to, let's say even if you're ingesting a string, right? If you're testing benchmarking with, let's say, string of 1 byte, and then in production your string would be too huge, multiple more than maybe 10 bytes. So your benchmarking would effectively mean nothing there. So I think this is one of the learnings I've learned.
Okay, thank you.
But other than that, yeah, I totally agree with.
Thank you. After, would you describe how do you approach benchmarking and performance?
Yeah, I think so. From my perspective, prior to joining Hazelcast, I came from market data. A busy day in market data was something around 30 billion messages, right, in a day. Comparatively, at the time, Twitter was doing about 1 billion a day, right? So that tells you the kind of throughput that we're talking about here. And then Hazelcast was able to do 1 billion in about a second. And you're looking at that thinking, wow, right? That's the level of scale that we have in terms of throughput. But not only that, you then look at the latency profile, and we're able to keep that envelope below 40 milliseconds. And 40 milliseconds is actually the envelope for market data. So if you think about the fact that you can run a Hazelcast platform and be able to handle the market data use cases on their busiest days, right the way through to potentially running Twitter as a platform. And you're able to scale from one end of the spectrum right the way to the other end. So running with Hazelcast, you know you're in safe hands. That's the first thing. The second thing is we're now trying to find new ways of adding even more load into the system to be able to now 10x that, 100x that. So you know that you have enough headroom in the system for it to just keep on growing as data rates and your requirements grow.
Right. So that's good to hear. So, I mean, it would be good, like, if you want to live today, you probably want to look at also what's going to happen next. You don't want just to know what's going on now, but also, like, how do you approach it, like, a year time from now? So, Tim, where do you see things going in terms of future for real-time stream processing?
It's always hard to predict the future, but we'll do it anyway. And we're either going to be massively underwhelmed or massively overwhelmed by our predictions. But a few things I'm already seeing. WebAssembly seems to be getting some interest there. I think that goes along with support for more languages for doing stream processing. You know, Python seems to be adding some libraries, maybe Rust, Kotlin, Go, Carbon, more JVM ones. I think that's a big one. Bigger scale. I've already seen some with a couple of my clients and some companies in China where you're starting to talk. They're well beyond terabyte scale. They're starting to build petabytes worth of data in real time, data warehouses within environments, within Flink, Pulsar, and Kafka. You know, 5,000 node clusters not being unusual, but maybe smarter ways of doing that hyperscaling. Definitely more machine learning and deep learning within the stream processing avenue. More load code development tools like NiFi, Dataflow Designer. I know Confluent's working on things as well. More dynamic hybrid deployments where maybe things shuffle around live between different cloud environments, on-premise, maybe even pushed out to the edge based on cost, nearness to data, what the application is, security requirements. Those are some advanced things you could do with some of the advanced data platforms out there. The coming improvements in Java 2021 and these future ones, once we start moving everything into those environments and can start taking advantage of Java Loom's virtual threading, we're going to see another level of scale. I think that'll drop the latency, make trillions of events a second not seem unusual. Also, we're getting more RAM, faster networks, more disk, where, you know, you get a laptop with 32 gig of RAM and you're like, that's okay. You know, my phone has 32 gig of RAM. You know, you're going to be pushing these numbers, so it'll make more sense that the scale is just going to keep growing. I mean, some people have been saying, let's tighten it up and just use the data that really matters. But until you've touched all this dark data, how do you know that it matters? Do you throw away every single blip from a device because you don't think you need it? Maybe there's things we don't understand, and maybe things that more deep learning will understand by looking at this data while it flows from the edge to any cloud and do that in real time. Lots of cool stuff is coming.
Thanks, Tim. Gunther, from your side, where do you see things going for real-time stream processing?
Yeah, I think it will become more and more mainstream as I see, more and more data is gathered, collected in different areas. And so this data, needs to be analyzed, needs to be transformed. And so that's where I think, stream processing platforms and systems will, get a higher adoption in the future. But besides, I think there will be more developments towards, SQL support or low-code environment support, as Tim already mentioned, which also supports this broader adoption and adds to the simplicity. I think that is important and a huge benefit for many users, as it allows like an easy steep learning curve. And I think another big aspect will be the integration with other systems that already exist. So via adapters, connectors, or like, so for instance, there's connection to Kafka from almost every system, but maybe also to other systems that store more like business data, like SAP S4 systems, or basically other systems that store data that are out there in industry and that have data that should be connected and enriched with basically streams.
Thank you. Matthias, from your side, where do you see things going in terms of real-time stream processing?
Probably like Tim and Gunther said, ML is the future of the real-time stream processing, because everyone wants to have ML in their companies, and it's pretty hot topic right now. And the real-time stream processing is a great place to put the ML model and have the output from this model right now. Also, like Gunther said, SQL is a great feature, and probably I guess it will be used more than currently, because a lot of people like analytics know SQL, and it is easy for them to use, so they could use the SQL on the real-time on the streams, not only on the databases. So I guess this is a nice feature, and I hope it will have a bright future. Also, I think that we could change batch processing to real-time processing, because some data warehouses are going to be bigger and bigger and bigger, and sometimes aggregations of these data warehouses are taking too long. So probably you can split some aggregations to the smaller parts and do that in the real time. So we put aggregated data in the data warehouse, or just going right now to the client or to the other systems which needs this data faster than right now. Also, moving to the cloud is the future, probably of whole IT, and the real-time processing, I guess, in the cloud is the future, and we probably in a couple of years will move to the cloud too. And the last thing, I think IoT is also a nice thing that maybe in the future will be more real-time aware, because right now we put all the data from some IoTs like some beacons or something like that, probably to the database. But right now we can do some aggregations in real time and then provide the information from these IoTs to process and to our another systems, not to store them in one place and then do something. So I guess that's all from me.
Thank you. Vijesh, what's your take on future of
Right, so,
Real-Time Stream?
Right. So I would like to start from where Mateos ended by talking about IoT, right? So with more and more IoT devices getting deployed, more and more data getting generated, combine this with the edge computing and combine edge computing with stream processing, right? The more lighter the more easier or more lighter stream processing applications are, the better it would be for the whole IoT domain, right? Because you don't have to, you would not have to necessarily send your data back to the central server to process it and then get the outputs from it. You would just get it from your edge. So that is one thing which I think would definitely we should look out for. Another one is the standardization of data formats. So what I mean by that is there are so many data formats available right now to process to send your data over the wire. But what I think would hit the right balance is a balance in terms of the efficiency of how your data transfers through the wire, and also the structure of the let's say the deserialized structure of the deserialized packet, right? The better your structure is, the less cleansing, the less mapping, the less validation you have to do, and that also helps you in evolving your format of the data. So this domain, I think, will also be in a better state than what it is right now. The next thing what I think we should look out for is the cloud aspect to it. I think this is cloud stream processing is, I think, gonna be used way more than what it is right now. Yep. So this is what I think.
Thank you. Manish, I would like to hear your part for the future. Where do you see things going in terms of real-time stream processing?
Yeah, I mean, I really think the real-time ML is going to be where the real value is going to come from. I mean, if we look at the apps we use, I mean, you look at Uber Eats, for example, they're able to do a prediction, right? When you're ordering food, they're able to predict that you're going to get your food in 20 minutes or 30 minutes. That prediction is based on some of the real-time features in the system, because you may be ordering from a place which has different traffic profile. The person who's delivering your food has different traffic profile. So these are high-value use cases, and we see some of our customers use that, but not everybody. I think that's where the future is. Even in real-time fraud, they are using the prediction algorithms or fraud algorithms are using stuff which is the number of transactions this person might have done in the 30 minutes ago, or based on their location. I think that's kind of really the future. So it's not about accessing data fast, but it's also about being able to predict based on not what you did yesterday, but what you're doing today. I think that's thing, and I think the big trend is that the batch, where somebody mentioned on the panel, was the batch workloads are going to move to real time. I mean, data is created in real time, and the reason why we have been using batch systems because that's what was available to us. So there's no reason for these workloads to be running on batch systems, or even Spark does micro batches, right? So why do that and move to real time? I think going to happen, and I think somebody touched on this low code aspect of it. Mm-hmm. I think this has to be democratized, right? Real time has to be democratized. We see large, a lot of our panels work for large companies, and not everybody has that kind of a technical acumen or army of engineers to build systems. So we need to lower the bar to entry into the real-time systems, and that would mean better tooling, low-code tooling and frameworks. I think that's where I feel that vendors like us and other vendors need to really innovate to make it more easier and democratize this whole solution building.
Right. So I think the future is bright.
Future is very bright. The future is in the cloud. I mean, I think one of the things which was touched was serverless, right? Why do you need to stand up these scale-out platforms? You should have a real-time API into the cloud, and that's what Viridian is about. We take care of all that heavy lifting, and all you get is an API and of your choice.
So what we'd like to do now is kind of like open discussion, basically open the chance for you to ask questions. So those who are online, feel free to type in your question. We will take this question, and if you want to ask a specific question for a specific member of this panel, feel free to name them. Otherwise, we'll just pick it up randomly. But the stage is open for you here, guys, if you want to ask any question, so feel free to do so. So I got one question. So,
Neil is excited.
Hey. Yeah. So, any takers? Anyone wants to answer it?
I can touch on that actually. I remember when I started, and the first thing I had to learn about actually stream processing itself, and that is you have to almost change your mindset a little bit, and that is that data is in motion, and it's constantly moving through, and you can look at that. You can persist it down, you can do something with it, but then you've already got to be ready for the next piece because that's already coming at you, right? So having this understanding that this data is on the move, and I've got to make decisions quickly on what I want to do with this data and have a clear mind about what you can do with that data as well. So as long as you have that right mindset, being able to essentially pick up that box, look in it, is it a box for me, is it a box for someone else, and just pass it on or take a look at this next box and see if this is something which I do want to deal with, then it makes a lot of sense, right? And he's starting to now begin to understand how that stream works, as opposed to having time to go open the box, take everything out, go have a look through everything, see if this is something which might be useful. That's very much the batch kind of way of thinking about how we process. So, you're going to be able to make those decisions that much quicker and that much faster. So being in that kind of mindset really, really helps. And that continuous query, it really allows you to be able to do that. So now you're moving away from this concept of I started something and eventually it's going to finish. It's just never going to finish. It's always there. It's persistent at all times and available to you all the time.
I think just to add, I think complex event processing has existed for a long time. It's nothing new. It's not like it came yesterday. I think the technology has evolved enough that we can actually make it a reality, right? You need to have these complex platforms in there that can process in real time and provide you meaningful feedback that influence people that are buying your products or making some decisions in real time. That's why it's become more and more useful now than it was 10 years ago, 15 years ago.
Okay, thank you. So this question is for you, Matthias. The question is coming from YouTube. So I'm just gonna read the question to you. So everyone is talking about real time. Can you give some examples of real value driven from AI machine learning being used in real time? How can I use it for real time values? So essentially, the question is, how do you apply AI machine learning on real time?
Oh, unfortunately, we are just thinking about that. Right now, we don't have that yet. We were looking forward to Python 3 in the Hazelcast Jet, I will be honest, because previously we had a problem that we couldn't use any TensorFlow and any other ML libraries. Right now, I guess probably we'll use the ML models. Okay, we need to have a contract with data scientists probably, because in our company, data scientists are the another team, and they have ML platform, and we need to connect with them with some contract. Yeah, so like it could be a black box for us because we can provide some data to the ML machine and retrieve the data as a source of this ML engine. So we don't need to know what really is there. We thought we want only the output of that. So if we provide probably some client information, the amount of some payment, we want to know only yes or no, this is possible client with huge money or outcomes, and we want to process the stream further for him, or just to split it and get another things. How to do that technically? Yeah, we are thinking about that. We don't have any solution right now, so unfortunately, I cannot answer probably for that question
Thank you.
As you want to.
Yeah, any more questions from the audience here? Yes, please. And there's a mic.
So my question is for you. So you mentioned about you process billions of events in a second. So what sort of technology do you use, and how do you decide?
Sorry, you mean specifically in terms of billions of transactions per second?
Yeah,
which technology did we use to do that within a second? You mean? Yeah. So that was actually done with Hazelcast. So as part of Hazelcast platform, you get access to Jet, which is the stream processing engine, and it was done through Jet essentially at that point in time. Sitting on top of obviously the distributed low latency store, you're able to actually now bring your compute to your data, and you'll be able to process that incredibly fast. And that's actually one of the differentiators when you look at what Hazelcast has and some of the other platforms. Because you're moving the data or the compute back and forth, it ends up giving you those latency spikes, or it ends up giving you a lower throughput as a result. But being able to have those two things mated together, so your compute is running as close to your data as possible, actually you can eliminate a lot of those spikes, and that's actually what allows you to go at that speed and at that scale as well.
Okay. And one more question for you. So, how do you scale? Like, do you completely rely on the cloud provider, or you just inbuilt, within your system?
Great question. Yeah. So for the serverless model we've talked about, we have metrics that sort of qualifies, hey, you hit this threshold, whether it's in terms of memory or CPU computation you're doing, we automatically scale out for you so that you can you get another member in the cluster, which means more data, more processing power. That's how we do it. Yeah. And we're using Kubernetes underneath, so we leverage some of the tools out there, not truly on the cloud provider, but we have metrics. The platform grows underneath, but depending on the data that you put in our clusters or amount of compute you use.
Okay, my last question for the Manish for you. So you mentioned about in Hazelcast, you are also implementing that machine learning. So is there any plan to include like intelligence based on that, anomaly detection?
Yeah, so we have a few customers who are already using us as a real-time feature store. So basically, they are able to inference ML models, which are able to predict based on the features which are persisted in Hazelcast. So that's available today. What we are planning to do also is to, bring some of the ML ops around real-time ML into the platform. But if you were to want to do real-time ML today, you can do that. So that's available in the platform. A lot of use cases for real-time ML are mostly focused on fraud detection, but we see also similar use cases in e-commerce and retail. So depending on a use case, that's something which is available today.
Okay, thank you.
Okay, thank you. So this question is for you, Gunter, about the benchmark you've done. So I'm just going to read the question. So it's been mentioned that data enhancement is a bottleneck when it comes to benchmarks. Have you done any enhancements when you did the benchmark?
Yes, I did. So I defined a certain set of queries, and some of them included basically enhancing the stream with data, stored in a database. So where you basically enrich the stream or combine the streaming data with some, historical business data, historical in the sense of it's stored in a database system. And so, it's completely right that brings a completely different topic into the game and can be, as mentioned, a bottleneck, and also needs performance optimization depending on the use case, of course. So the benchmark allows basically to evaluate different enhancement, enrichment techniques or methods, and also allows to basically exchange the database management system or the system that stores the data. So to sum it up, yes, I also covered that part in the benchmark.
Right, thank you. So I just want to remind everyone if they have any question. So Vijesh, this question is for you. So when it comes to real-time stream processing, the question is, how do you deal with very large data sets? So is there a recommendation or best practices for handling large data sets?
So the way I would like to, I think I would like to maybe drill down on what very large data set means, but the way I see it, you could treat your large data set as a stream, right? It's essentially take one piece of data from your data set one by one, keep processing it. So that's one way to look at it. If I got the question correctly. Then another way could be to take your data set, take it as load it in memory somehow, and then do the stream processing. That might be one way to kind of optimize. But that's what I think.
Okay, thank you. Any more questions from the audience here? I know we're running out of time, but we will stick around if you have any questions here. Just to make sure that we get the online questions first. So this question is for you, Tim. Do you see any value from integrating various tools when it comes to stream processing?
Yeah, the value I see is picking the right tool for the right part of the process. Like something that load code to do the basic thing, get the code going, and then maybe more complex part in either Hazelcast or Flink. And again, with maybe Kafka being between them, so you could spread it out. Like you were talking, those big data sets, to me, big is at least terabyte, if not petabytes of data. You're going to need to distribute that among a lot of nodes. Now, they might be big nodes, but most people don't want to put a petabyte into one machine's RAM. I mean, that might be distributed among 100 or 1,000 machines, each with 32, 64, 128, even more cores per machine or per virtual environment, you know. And then once you're splitting it up, maybe different things are processing that. Maybe Hazelcast is processing part of a big job, Flink another. You could have multiple systems doing what they do best. Maybe someone has a really good ML library in a stream. That tends to be the part. And again, Kafka or Pulsar, so I could distribute those workloads out, maybe to different servers, different clusters, different availability zones, maybe some on-prem, maybe for those IoT use cases, do that processing at the start, at the edge, because I can run a lot of these workloads now on those edge machines, whether it's an edge gateway or a big device. I mean, you look at, I've got a Jetson Nano and some other NVIDIA devices that have 16, 32 gig of RAM, you know, GPUs, 20, 30, even more cores of regular processing. So I could do some of that stream processing on IoT when that data starts. So pick the best piece, you know, stitch them together with something like Kafka or Pulsar so I don't lose those and I could distribute them. And then if you want to simplify these things later, you could pull some pieces out and maybe use less. Depends on the use case.
Yeah, I guess the key word here is simplicity when it comes to the integration. So the last question is actually for me. So someone is asking how they can contribute to our community. So I'm not sure if Martin is online, so I would like just to introduce Martin Kirst. Are you online, Martin? Yes, no? So we run a Hazelcast Hero program where you basically be part of our community. It depends on your contribution to the Hazelcast or Real-Time Stream Processing community. So there are various ways to do it. Obviously, it depends on your contribution. So if you're interested in this program, feel free to reach out. Actually, it's quite good program in terms of the community. So you get to see what type of issues exist, how you can approach it, and you also get the support from our engineers as well. So it depends what you want to do. Obviously, it depends also on the use case that you're trying to achieve and how you want to be part of this community. So feel free to reach out if you want to be part of this program.
Hi, Fawaz. This is Martin speaking.
Hey, Martin. How's it going?
All good.
I think, yeah, I wasn't sure that's if you're online or not. So, I mean, it's good to speak to you. So would you like to just give a quick intro and your contribution to Hazelcast?
Yeah, absolutely. My name is Martin Kirst. I'm located in Berlin as well, working for a company called Oliver Wyman, which has probably the least technical association here in this call. We are a strategic consultancy company. What little people know is that we also have a large group of specialists, how we call this, which are architects, data scientists, data engineers, and so forth. And we're supporting our clients in various challenging large projects from finance to automotive and insurance.
So what was
in terms of my contribution?
Yes.
Yeah.
What was your contribution?
You asked for. Yeah. the story is a bit longer. I built a little pet project, which is all about a library for business process modeling notations. So process BPMN workflow, so to say. While we're having this in place for a client in a real world, larger customer management platform, I came to Hazelcast because in the setup of processing workflows, you can imagine that there are a lot of events are emitted. Like if somebody enters a data for his meter read, this is an energy retailer I'm talking. So all of these events, they are processed by the Hazelcast, and so it's processed by the engine and then exported as event in a real-time fashion into Hazelcast ring buffer. And this is the moment where my contribution chimed in, because at the time being, roughly a year ago, the Go client of Hazelcast didn't support the ring buffer, what the server or the cluster already does of Hazelcast. So I contributed the client part, so to say. And yeah, I'm glad this worked out. And I'm also glad to share this as part of the release 1.4, if I'm fully right, Fawaz.
Yeah, that's great to hear. So if anyone is interested in Martin's work, so we had some, content out of it, like blog post and Twitch live stream. So feel free to reach out to see the links or view the content. So welcome to the Hazelcast Hero program. So it's great to have you, Martin, on board. I think your contribution is really valuable for the community. And yeah, it's great to have you. So thanks very much. Thank you.
Thank you. Thanks for having me.
Thank you. So just to finish off, so this is your chance, basically, because we wanted to make sure that you are part of this community. So it is your chance to, have your input. You will get survey, but at the same time, you get your chance to win Nintendo Switch for people who are joining virtual. So you just need to scan this code. Those people are really in this meeting. So we'll do draw just after we finish. So with that being said, I would like to thank everyone attended today in person and online, and also would like to thank speakers. So any final words, Vishesh, from your side?
No, I mean, thank you for having me. It has been a great 1 hour or so. Lots of different perspectives to hear, lots of takeaways. So yeah, looking forward. The future is bright.
Thank you. Gunther, from your side, any final words?
Yeah, thanks a lot for having me as well. And yeah, it was a great discussion. I learned a lot. Yeah, thank you all.
Thanks. And Matthias, thanks very much for being with us today. I know that you had a busy day, so any final words?
Thank you for inviting me. It was a really great experience to see all the perspectives. Probably I will, after this unconference, see the Gunther work with PhD. I need to check that. And thank God for this opportunity.
Thank you. So Manish, this is like final questions. I know I asked too many questions. So what is the 1 or 2 takeaway messages for audience for using Hazelcast? What would you say in terms of real-time stream processing takeaway messages?
Yeah, I think the takeaway one for me is, we had a great panel of folks speaking about use cases. So this stuff is real. We have 200 plus customers across the world. And thousands of users on our platform. So, and we really are building the future of real time. We want to become the system of record and system of engine for all real time applications. We are on a journey, and as Avtar mentioned, your journey could start anywhere. It could start with basic low latency data store, move to streaming, and then to more high value real time ML use cases. The Hazelcast platform and the open source projects really enable you to start the real-time journey and power the real-time applications.
Thanks, Manish. So with that being said, I think we run 20 minutes over, so I apologize for this. There's more food downstairs, so feel free to grab some food. Some folks around here, if you have any specific question, what I would like is to hear your part of story. So what kind of use cases you have, what type of problems you have. That's why you're here, right? So you want to know the solution. So stick around, describe your problem, describe your use case. For folks online, feel free to reach out. I know that we will end this call live stream, but we're available online. Our Slack community is very active, so feel free to join the Slack community channel. I think someone will post the link over there. And we look forward to seeing you again later this year. So feel free to suggest where we should host next meeting. Thanks everyone for attending, for speakers, for the panel joined here, for everyone involved, for the guys who managed to do this live stream 100% correctly. I know that sometimes you run with technical difficulties, but today it was really perfect. So thanks everyone. Feel free to join our lunch, dinner. So sorry, dinner for us now. It's getting confused for me. So yeah, thanks to everyone. Let's just have some food. Thank you.
Recording stopped.